In section 1.3, we cover the properties that are most common, and they are true in the set of real numbers. And we're going to start out with the field properties. The field properties state that, given any set of numbers, these properties hold true. These are the rules for algebra. And the very first one, I think, is probably the hardest one to understand, is the closure property. And what it basically says is that if you take any two real numbers and either add them or multiply them, you are going to end up with yet a unique real number itself. So what that means is that if you take like 3 plus 2, which are two real numbers, you're going to end up with a real number. 3 times 2, which is 6, 6 is a real number. This is not always true with every single set of numbers. For example, if we talk about something very specific like odd numbers, just talking about the set of odd numbers, if I would add two odd numbers together, I am not going to get an odd number. So there are sets of numbers that are not closed, but when we talk about the whole general set of real numbers, the whole general set of real numbers is closed and follows the closure property. The commutative property of addition, commutative basically means that if you have 3 different numbers or more, it could be 5, 6, whatever, it doesn't matter what order they are written in, B plus C plus A, it doesn't matter, you're still going to get the same sum. So if I take 5 plus 6 plus 11, I am going to get the same thing if I take 6 plus 11 plus 5, or any combination. I will always get the same answer. That commutative property of addition can swing and apply to the commutative property of multiplication. If you have more than two numbers, it doesn't matter what order that you multiply them in. I can switch up the order anyway, and I'm still going to end up with the same answer. So commutative properties refer to the order and the order being switched around. Associative property and commutative property is often confused with each other. Associative property states that the order doesn't change. So if I end up with 3 or more numbers, and the order doesn't change, but how I group them does. So if I take A plus B first, then add C, or if I take B plus C first and then add A, I would get the same answer. So if I have 5 plus 4 plus 3, where the parentheses are around 5 plus 4, order of operation tells me to do that first. Or 5 plus 4 plus 3, here I'd have 9 plus 3, which is 12. Here this is 5 plus 7, which is 12. So the order doesn't change, but how they're grouped does. The same is true with the associative property of multiplication. You can take any 2 or 3 or 6 or any amount of numbers and not change the order, but change how you group them. So this is 6 times 5, which is 30. And this is 2 times 15, which is also 30. So again, order doesn't change, how you group them does. On the identity property states that there is, in addition, there is one value that if it's added to any number does not affect its value. And that identity number is 0. So the identity of addition would be shown as 5 plus 0 or A plus 0 is equal to A. That identity value is 0. So this shows the identity property. So in multiplication, if I am talking about the identity property, it states that there is one value that if it's multiplied to any real number, it does not affect the value of that real number. So you can take any number, any real number, times B and still end up with B for your answer. I'm going to jump down and talk about the inverse properties, because the inverse properties, they tend to get confused with identity properties because there is some similarity. The inverse property states that if you take a number and add its opposite, you actually end up with the identity value. You end up with 0. So if you take like 5 plus a negative 5, you would end up with 0, a number and its opposite. The property of reciprocals states that if you take any number times its reciprocal, you end up with the identity value, which is 1. So if I have C times 1 over C, I would get 1. So they're kind of tied together as far as the identity value, but they are different. The distributive property is a really common property in algebra. We use it a lot. The distributive property states that if you have a quantity, let's say B plus C, and it's being multiplied by another factor, this outside factor can be distributed, and this would end up being then A plus B and then A plus C. So the distributive property actually distributes this outside value to both of the terms inside of the parentheses. The distributive property also can be represented in reverse. If you have x times y plus x times z, then we can take, because they have x in common, we can take that x and rewrite it so that x is times that quantity y plus z. We often call this factoring, but factoring really isn't a property. So if we see this, it actually refers to the distributive property. That's actually the correct terminology there. The property of equalities all have to do with being equal. And these are ones that you probably saw in geometry a little bit more. The reflexive property states that if you have one value, it's equal to itself. So C is equal to C, 5 is equal to 5. The symmetric and transitive property you are going to see often written in if-then statements. Those are probably the key ways of identifying them. It basically states that if x is equal to y, or if x is equal to y, then y is equal to x. Okay, so if x is equal to y, then y is equal to x. The transitive property just takes it a step further and says if x is equal to y and y is equal to z, then x is going to be equal to z because they are both equal to the same value of y. The very last two properties are often properties that are misused. The addition property and the multiplication property all refer to equations and equation solving. So if I have the equation x plus 3, and it's often written as an if-then statement, x plus 3 is equal to 5, then the addition statement says that if I add the same value to both sides of the equation, I get an equivalent equation. Okay, so in the addition property, it has to be an equation, and they have to be added to both sides of that equation, the same value. Okay. So we often see that in equation solving. If I have like x minus 8 is equal to 2, in order to solve for x, then I add 8 to both sides. This is the addition property in this case. Multiplication property states that if you are multiplying an equation, if I have like 3x plus 6, I can multiply anything to both sides, and I will end up with an equivalent equation. Okay. So it is often seen in terms of equation solving, where you might have like 2x is equal to 8. If I multiply both sides by 1/2, or we think of it in terms of division, then I end up with an equivalent equation. The multiplication and addition properties refer to equation solving. And I just want to emphasize that.